Hello everyone, this is Simran Ved Pathak and today we are going to learn about design patterns. I'm even going to start a series of single of DSA as well as design pattern. This design pattern will cover everything and DSA series will also range from arrays to tries. Now let us start with singleton design pattern. You must have faced a problem of creating a database connection only once so that I don't need to instantiate or create an object in order to connect to the database every time I create one object. So this connection from database to throughout the program only once can be done using creating a single object. For example, take an example of logger itself. The logger object should be created once and I can access it throughout the program or project in order to log the issues in the program. Similarly, we have singleton design pattern. We create only one object throughout the program and it is accessible everywhere. Now, as you know that private constructor doesn't let me initiate or instantiate one object. What helps me to instantiate one object is the default constructor. So in this program, as you can see, I have created one private static singleton classic singleton instance, and here we have private classic singleton as our constructor. This constructor is common throughout the program, but there is a reason that this cannot be accessed everywhere. It is because it is private. Now next, since both the properties are private, I need to have something which will help me to get the object, that is instance. So I've created one public static classic singleton get instance. Now why get instance is also static? It is because many object can access this get instance. In order to create only one instance of this method also, I have created it as static. When I run the program, I do get my response as yes, we are both the same object. We didn't got a response as no, we are not. Now there is one issue in this method. That is, I'm checking the instance only once and I'm checking if it is null or not. What if there are two threads entering into this if case? Once the instance is null, that is fine. Second time again the thread enters, that is parallelly, and at that point also I'll find that instance is null. So the property of singleton pattern is violated there and then. In order to avoid it, we will use the concept of double check singleton design pattern. What do we do over here is, let us write a program for it. This is double check singleton design pattern. Okay. Now here again I'll have private constructor with a private static double check singleton instance. This is the instance which I want to access. Now I'll again create one public method which will help me to access that object. As you can see, I am again doing the same thing. So your question will be, Simran, isn't this the same method which you were doing previously? Isn't this wrong, bro? I mean, yes, it is wrong. Wait a minute, I am giving you the answer for this also. Okay, this was the same pattern which we used for classic singleton design pattern, but here comes the twist. I'll create one object known as private I'll create one object known as private read only, private static read only object. This is a classic object, if you know, is equal to new object. Now what lock helps me to do? It helps me to check if the lock, as in if the thread has visited this lock. It is similar to this pattern. Suppose this is the memory of lock. If a thread enters into this lock, then this thread or this lock is now filled with one thread and no other thread can enter into it. This is the concept of the lock. So what happens over here is, I've created a lock. Now what my mind says to me that everything is running right, but there is a reason why we are calling it as double check singleton. It is because I have checked if instance is null for the first time. Now once the lock comes in, once the thread comes in, we get the new instance. But what if there is again a parallel check towards this lock? So I'm going to give an instance is equal to null check once again. If the object is not created, it will go into this instance and yes, I'll get my answer. Now I'll just write the pattern in this form. So we are getting one thing, that is, these are few of the warnings. As yes, we are the same object. Now let us move on to other part, that is lazy singleton design pattern. What does lazy singleton design pattern do? There is a concept of lazy helper function which C# provides you. This lazy singleton C# helper helps me to create an object or create an instance of an object when I want to create one. So here the basic concept of private static lazy hash. I'm creating a lazy. The type of this will be lazy singleton object over here will be instance is equal to new lazy. Okay, so the type will be lazy singleton, and the instance name would be instance new lazy of and the object will be created only when I wanted to create. When I want to create it, so that will be new again. We will have a private constructor, the public static lazy singleton get instance method. Here I'll do one thing, that is to have access of the instance. I'll just write return me the instance dot value. That's it. This will do. Well, now you can see there are many things which is very much odd at this point. That why do I have a value here? Why do I have a lazy wrapper here? So take one thing into your mind, that lazy is a singleton wrapper provided, helper wrapper provided by C# itself. Instance.value helps me to create that object. Now, the moment of truth. I hope so there are no errors. Okay, we have got one. Non-invocable member dot value cannot be used like a method. Okay, that's weird. Private static lazy singleton underscore instance is equal to new lazy of lazy singleton. I think so I've done it right. I don't know why it is wrong. Okay, I've got the error of why this error was. So value is not a method, it is a property. So it cannot be accessed with the brackets which I was using. Now, as we have seen double check singleton pattern, there was a concept of thread safety. Now, as a beginner, you will get this question, how is thread safety handled here? Here, thread safety is handled by CLR itself. CLR is Common Language Runtime, which helps you to create a single object, that is a thread inbuilt thread safety object. So if I'll run the program, I'll get the desired answer, that is, or a standard answer which I was expecting, yes, that we are the same object. Now the final way of me writing a singleton pattern is in eager singleton pattern. In eager singleton pattern, What I'll do is, again I'll create one object, that is object. Before object I'll create a method, and then I'll create a private static eager singleton underscore instance is equal to new eager singleton. Again we'll write the same method as that we have wrote in classic singleton design pattern, but here I don't need to check if instance is created or not. I'll just return my instance. So let's get a thumb rule here, that is creating, let us save everything. Oh my god, the type or namespace name singleton. Okay, I've made a mistake here. It should be T. Okay, so where is this error at? Singleton design program. Cannot implicitly convert singleton pattern classic singleton. Do we have a classic singleton here? To eager singleton. Okay. What is exactly causing the issue? Okay, we have defined a classic singleton. Okay, we have got the desired answer. So the main motive of creating this video is me getting on the skills of programming, and you can also learn from it the mistakes which I made in this video. For example, I need to know why private is static read only, why it was specifically read only. It is specifically read only because, what if I write it as lazy singleton but without read only? That will also work, but why do I need only read only, है ना? Okay, so read only is assigned because if I won't write read only over here also, I can create an object out of it. For example, there's an object and now I can create eager singleton, and this will also work. Why this will work is because of the fact that I didn't assign my eager singleton as read only. So if I write over here read only, it will give me an error. That is, I can't assign. A static read-only field cannot be assigned to in a static constructor or a variable initializer. The build failed, fix the build error and run again. So if I'll just comment this out, I'll get the answer which I was expecting. That is, yes, we are the same object. So that is the purpose of creating a read-only method. No creation of another object, no instantiation of that object, because I'm already assigning it. I'm just accessing it through a property. So I don't need to create it as only static. I'll create it as static and read only. Now another question, folks, around lock. I think I was not able to explain lock very clearly. So I'll learn about it and explain it to you today itself. So in simple terms, you can understand lock as a lane where there is a traffic light. You can enter through that lane only if you have a ticket to that road. If you don't have a ticket to that road, you won't be able to enter that lane, or you can enter it one by one. Once your car is up through that lane, the second car can enter. But since only one car was allowed, since the instance was created and instance is not null now, the second thread won't be able to go inside. So lock is something like my first thread was created. When the second thread came in, lock did allow me to go through that lock object, but thread 2 also had that key because thread 1 left that key to thread 2. But was instance null? No, the instance was not null. So we achieved the concept of singleton design pattern here. So there are 4 ways, that is classic singleton design pattern. You simply create one instance and then you return it. Not so safe. Then we went to double check singleton. Here we create a lock object that should be read only. If you'll create one object which is not read only, you can create multiple instances of that lock object, and hence there will be many keys, many thread can enter, many instances will be created. Hence the issue. Next we will have is lazy singleton. That is, you have a lazy helper wrapper class provided by C#, which is already thread safe, which already handles the where underlying CLR, that is common language runtime, already handles the singleton or the thread safe issue, and hence we can return the instance. The second part is eager singleton design pattern. Here you create only one object out of the here you create only one object, that is at the instance when the instance is actually defined or declared, and you return the instance there, and then you don't need to check any lock or there. So according to me, eager singleton is not the best singleton pattern which you can use, because this will reuse or this will create unnecessary usage of memory. So I would prefer checking for lazy singleton pattern, or we can go with double check singleton pattern. So that's it for today, guys. This was design pattern for singleton pattern. Let's meet for our next series, that is DSA topic over heaps. Until then, good night and study hard. Bye, guys.